Okay, we are on section 9.3, surface area of three-dimensional shapes. Uh, I wanted to just go through some of these again. I was rushing through to get through the formulas and things like that, and I wanted to take a little bit more time on the video to show where these formulas come from and how you might remember them, because that's going to be part of the hard part, right? So looking back to number one, which we did in class, example number one, right? It's a triangular prism. And I gave you the formula, but again, I want to show you where it comes from again. But before I do that, let's go back to the cylinder. Now, remember when I unrolled the paper towel thing we had in class, to find the surface area, we ended up looking at uh, the curved surface on the outside where the label would be, right, or where the paper towel was. Ended up, when you unravel it, it ends up being a rectangle, right? And that rectangle has a length of the circumference of the circle, because it's really this outside part of the circle which gets unrolled. And you may want to take a soup can or something like that to look at it. Take a soup can out of your mom's cabinet, your mom or dad's cabinet, grandma's cabinet, whoever's cabinet there, and unroll that, a Gatorade bottle, whatever. You take that off, and it's going to be a rectangle, right? And you'll notice that the top, of course, is a circle. So you've got the area also of a circle, but you've actually got two circles. You've got two circles, and you've got a rectangle. The area of the rectangle is going to be determined by the length of that rectangle, which is, the length of that rectangle, which, why is this happening? The length of that rectangle is the circumference, right? That's this part right here. But the width of that rectangle, or the height, whatever, if you want to call this the base and the height, depends on what you're doing. This height here is the height of the cylinder, right? So this is the circumference of the circle, which is the circumference of the base of uh, the cylinder, and then the height of the cylinder. So the area is going to be the circumference multiplied by the height, the circumference of the base multiplied by the height. Okay. Each of these circles, of course, is just pi r squared if you know the radius. So when you add all those together, right, you get pi r squared times 2, because there's two of the circles, right? 2 times the area of the base, plus the area of the face that's curved on the outside, which is c times h, right? Now, we could say that the circumference is 2 pi r multiplied by h for that rectangle, right? This is also 2 pi r times h, because 2 pi r is the circumference. And then we could factor out the 2 pi r, say it's 2 pi r times r plus h if you factor it, which again, you could just turn back into circumference if you want, r plus h, okay? Now, any one of those formulas works, right? You could just kind of do this, everything separately, find the area of the two circles, find the area of one circle multiplied by 2, and then do the circumference times the height. If you want the factored version, there it is right there. If you want the factored version with actually the c written in, you can do that. Okay, that's where we get the formula. You should be able to reproduce this. I would expect you to be able to reproduce this formula, at least this part right here, right? Because you pretty much know all that stuff. Okay. Now, for some reason, again, this thing did not work itself out here. Now, the cone is something. Well, I wanted to go back now. Now that we saw that with the cylinder, sometimes it's easier to see with the cylinder than any other prism. But the prism still has the same idea here. If you look at this prism, this triangle, which is the base, right? Each of these sides, I've got three sides. I've got a side here, I've got a side here, right? Let me just erase all this stuff. I've got one side here. I've got another side over here. And I've got another side over here. I got three sides of that triangle. Now, imagine similar to our cylinder, if we had a wrapping around the outside, not including the bases, but just a wrapping covering the three rectangles that we said we had. Right, there's a rectangle in here, and that rectangle looks something like this. Okay, we know it's got a side of 15, and this side here matches the blue side, right? This blue side here matches this side. So imagine I just kind of turned it on its side. Okay. Now there's another rectangle over on this side that you can't see. Imagine I colored it purple. And it would be, I could attach it to this red one that I drew over here, right? Oops. This is the red one. There's a purple one over there. Imagine I attach that over here. Now it also has a height of 15, right? So those sides match. Those are all 15, right? And we were told that this, let me just draw in that highlighted side. That's that side right there. So that same side I put in yellow on the left is this same side over here. There's one more on the bottom. Imagine I colored it black. There's a rectangle on the bottom. Let me erase everything else for a second. Ugh. There's another rectangle on the bottom that's not drawn in, right? Because it looks, there is a, oops, still not doing that right. There is a missing side that you can't see, the triangle on the back. That's another base, and you've got these sides. So that this black one that I'm shading in here, I'm going to draw over here. Again, it's got a height of 15. It's got a height of 15, and the base is actually 13. And I can't remember the color. What color did I actually use there? I think I used green. I highlighted it green before. This was the green one. That matches that one. Okay. So again, let me redraw these in. And the purple one. No, that was the blue one. So now look, the blue, the yellow, the blue highlighted, the yellow highlighted, the green highlighted over here, right? This would be the black rectangle that I drew in. This would be the purple one that I had drawn in. The blue plus the green plus the yellow actually are the perimeter of the base, right? And now I've got another rectangle, similar to the way I had a rectangle down here, I've got a rectangle up there, right? The rectangle comes from the outside of that cylinder, everything not including the two bases. So we had two triangles up here, we had two circles down here, number two. We had two triangles on number one. And you'll notice that either way, when we unwrap that thing, we have made a rectangle that has a side of 15 and the other side being the perimeter. Now down here, it's the circumference. Up here, it's the perimeter, right? This side right here is the perimeter because it's all the sides of the triangle added together. So we could say, in general, right, with any triangular prism, we would have the perimeter of that triangle as the length of the bottom of that rectangle that we unfolded, and we would have the actual height of the rectangle as that part, right? And so the area of that is P times H. Now, the surface area total is going to be P times H plus 2 times the area of the base. Remember, we talked about big B being the area of the base. So that's the formula, which looks kind of similar to that one, right? We have 2 times the base plus circumference times height. This is 2 times the base plus perimeter times height. Same idea.